Yes. Welcome to the class for today. Today we want to look at these questions ranging from simple equation to inequalities that's under basic algebra. So my student is already in class attempting the questions, but let's look at it together. So here we want to find A. To find A, we take 24 to the other side, it becomes minus. So A equal to 39 minus 24. So if I remove 20, I got 19. Then minus 4. It should be 15. 15, yeah. Then the second one, if you have 39 equal to b minus 24. So to find b, you take 24 to make 39, then it will become positive. 39 plus 24 equal to b. So b should be the addition. If I had 20, I have 59. Then plus 4, that should be 63. Then you have another step here. We're looking for c, but there's a number beside it. First, to take away this one to this side, like adding 10 to both sides, it's going to change to positive 10. Then you have 4c equal to 26 plus 10. So 4c equal to 36. So 4 times 9 is 36. C must be 9 because you divide both sides by 4. 4 cancel 4, then you have c equals to this, which is 9. Then here you have to cross multiply this times this and this times this. Or simply put, multiply both sides by 4 because it's division. So 4 cancel out 4. You have d minus 3 equal to 44. So d equal to 44 plus 3. And that will be 47. Now to the other aspect of these questions here. We have Dora has solved this and got 19. Explain Dora's mistake. Okay. Dora did not multiply 3 and 2, instead added. That's the mistake. So we have to find the correct solution. You have to say 3x plus 6 equal to 62. So 3x equal to 62 minus 6. 3x equal to, if I remove 6 from 62, I have 56. Yeah, because if we remove 2, you get 60. If you remove 4, you get 56. Then divide both sides by 3. So you have x equal to 56 over 3. How many 3 goes in 5? That's 1. Remainder 2. How many 3 in 26? That's 8, which is 18. And remainder 2 over 3. Then the next one, this is inequality, which is greater than. So you open the bracket, 4c minus 12 greater than 10. Then you take 12 to the other side. It becomes plus. That is 10 plus 12. That's collecting like terms. And 4c equal to 22. C is, not equal to, it's greater than. 4c greater than 22. Then you divide both sides by 4. 4 cancel 4, then you have c equal to 11 over 2. Oh, not equal to. Why am I using equal to? Greater than 11 over 2. And the answer will be c greater than 5.5. So we should take note of that. And then I go to the next page. Dexter is thinking of a number x. 2 more than 3 times its number is the same value as 13 less than 5 times its number. Okay, we have 3 times its number plus 2 is the same as 13 less than 5 times its number. 5 of its number minus 13. So we want to find this number. This is an equation that can help us solve it. And to solve the equation, I can move this 3x to be the 5x. So I have 2 plus 13 equal to 5x plus 3x. I mean minus 3x because the 3x is going to be, it was positive, it's going to be negative 3x. So this is going to be 15 equal to 2x, or 2x equal to 15. Then x should be 7.5, which is 15 over 2. Let's think about it. If x is 15 over 2, just to check whether we're right. If it was thinking of 15 over 2, if we had 2 to 3 times of that number, times 3, then plus 2, is it going to give us the 15 over 2 times 5 minus
I'm
13?
just gonna check on the fate of the oven, sir.
All right, no problem. So whether this is going to be equal is what we are trying to look into now. So 15 times 5 uh, over, 15 over 2 times 5, that is 75 over 2 minus 13. Okay, and this is 45 plus 2. What would that be? Let's see. If I got 45 over 2, then plus 2, will it be equal to 75 over 2 minus 13? Let's check. There's no harm in trying and see. So the LCM here is 2, 2 here 1, this is 45, plus 1 here 2, 2 times 2, that's 4. Then will it be equal to the other one, which is also 2, this is 75. Then 1 here 2, 2 times, that's 26. So will it be equal? What we're saying is that this should be equal to this. Let's check. 45 plus 4 equal to 49. Then 75 minus 26 will be equal to, this is 15 minus 6, that's 9. 6 minus 2, that's 49. So that means our answer is correct because it gave us 49. So that means this is 49 and this is 49. So it's equal. And since we divide by 2. Okay, let's leave that aside. Then the other one here says you should solve 2 greater than this expression. Okay, I have to move this expression to the left and move 2 to the right so I can keep my sign here. So I'm going to have 2y now greater than 6 minus 2. So 2y greater than 4. Then if we divide both sides by 2, y greater than 2. That's going to be the answer. I think so. Now to the second page of this work. The equation of a straight line is given as this. Write the equation in the form mx plus c. So we have to make y the subject of the formula here. What we're trying to say is that find y. How can we find y from x equal to 2y minus 1? So if we keep y here and move the 1 to the other side to meet x, it's going to become x plus 1 because 1 was negative. Now it's positive, equal to 2y. Then you can divide everything by 2. This over 2, this over 2, and this over 2. This cancel this. So you have y equal to half x plus half. So then y equal to mx plus c. So here we can say m is half and c is half. Okay, that will be that one. Now this one says make p the subject, make h the subject. You have to free h. How can we free h? That's very simple. You just square both sides. So you have p squared equal to the square root of 2h over 5, also squared. Why am I squaring both sides? That's because I need to remove the square root. So you use a square. If it's cube root, use cube. If it's its fourth root, use power 4 to remove it. So whatever you do to p, you must do to the other side. Or whatever you do to the other side, you must do to p. So we have p squared equal to 2h over 5. 2h over 5. So you can multiply both sides by 5. So this times 5 here then times 5 also here. So that 5 here can cancel this 5. And you have 2h equals to 5p squared. Then you can divide both sides by 5 to get your this. So I mean by 2 rather, because you are looking for h. So you can say that h equal to 5p squared over 2. So that'll be the solution to that one. Then we have another page here. This one says circle the prime numbers. We know the prime numbers have only two factors, 1 and the number. This is also prime number 1 and the number. This is also prime number 1 and the number, no other factor. But these ones have more than that, and 1 is not a prime number. So the prime numbers are 2, 3, and 11. Decide if each statement is true or false. Explain your answers. All the factors of 20 are less than 20. That's not true because 20 is also a factor of 20, so we cannot say all of them are less than 20. The factors of 20 are 1, 2, 4, 5, 10, and 20. So, how do we say they are all less than 20? So, it's not true. Then, multiples of 4 are also multiples of 2. Well, shall we say that? If I say multiples of 4, what are multiples of 4? Uh, let's say 4, 8, 12, 16, 20, 24, 28, 32. Yeah, all multiples of 4, because all these are multiples of 2. You can say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So in as much as 4 is a multiple of 2, then all multiples of 4 should be multiples of 2. The answer is yes, they are. X equal to 5 is a solution to this. Let's check it. 12 12 minus 7 equal to x. And that's 5 equal to x, so x equal to 5. So this is correct. Then let's see the second part here. This says, are the statements always true, sometimes true, or never true? Circle your answers and explain your reasoning. Multiples of 3 are odd. Multiples of 3, no. It's sometimes true. Multiples of 3 because 3 times table we have 30, which is not odd. We have 24, which is not odd. We have 18, which is not odd. We have 12, which is not odd. So sometimes true. Yeah, we can say sometimes. Sometimes true, not always true, and not never true. So that is the explanation there because some of them are odd and some of them are not odd. Some of them are even. We're going to continue shortly. Let's see. All right, we want to continue right now. This one says when you had two prime numbers, the answer is even. Let's check. 2 is a prime number and 5 is a prime number. This is 7, which is a prime number not even. Let's check another one. 5 plus the next prime number, 7. This is 12, which is even. So that statement is sometimes true and not always true. So we can say that it is also sometimes true. Okay, show that this is one third of this. How can we show it? 10% is 10 over 100. And we want to multiply by 50. Okay, we can say if we divide 1 over 10, yeah, 10 here 1, 10 here 10. So we have 1 over 10 times 50. That pen is not showing well, so 1 over 10. I'm going to write it again. 1 over 10 times 50. And this is not even something to consider because 0 can cancel 0 and 1 times 5 is 5. So, and let's check this one. 1 over 3 of 15, right? Yeah. So this 3 here 1, 3 here 5. This is also 5, so they are equal. In other words, we could try to solve the two. Solve them step by step and see whether they are going to be equal. So we have 10% of 50, then we have 1 over 3 of 15. So two zeros cancel two zeros. Let me use another column. Two zeros at the top cancel two zeros at the bottom. Then we have 1 times 5 over 1, which is 5. Then 3 cancel 15 to give us 5 times 1, which is 5. So they're equal. Okay, now the last page, the last question. Want to expand this? This is 4x plus 12. So that is 4x plus 12. Let's use white color this time. X squared plus 4x. So this is x squared plus 4x because you multiply. Use what is outside to multiply everything in the bracket. Now you have a bracket times a bracket. Very simple. Use the first one to multiply the whole bracket. That's like saying x into the second bracket. Then use the second one to multiply the whole bracket. So that's plus 5 into the second bracket.
Okay.
And we have
Sure took
x
that
squared
long, but I completed
7x.
it.
Okay, you are true, right?
Yes.
Okay,
Now we just need to do the correction.
okay. You have the marking guide, or we should just look at it together?
I have the marking guide with me.
Okay, you can try to mark
Well,
it
there's multiple, so.
and see if there's anyone you need an explanation with.
Okay. There pretty definitely will be.
Okay, so let's see. Right, so what we have here is 7x plus 5x, that's 12x. And this 35 remains here, and this x squared remains here, so this is the answer. And this one, Nija is investigating the sequence given by the rule 4n plus 1. She makes two conjectures. Test the two conjectures to see if she's correct. So all the terms in the sequence are odd. Let's check it. 4n. 4n will always be even, and whenever you add 1, they must always be odd. For example, 4 into 1 plus 1, that is 5. 4 into 2 plus 1, that is 9. 4 into 3 plus 1, that is 13. 4 into 4 plus 1, that is 17. So this is true. Let's check the second one. It said 203 is not a term in the sequence. Let's check if it's going to be. Um, we'll say 4n plus 1 would not be equal to 203. Yeah, it won't be if we cannot get whole numbers. So let's say 4n plus 1 equal to 03. That means 4n equal to 03 minus 1. 4n equal to 02. Then n equal to 02 divided by 4. And 4 in 20, that's 5. And 4 in 2, that's 0. Remainder 2 over 4, which is going to be 50.5. So since this is not whole number, it shows that 4 cannot divide 203 evenly. So this is also true. It's not a term in the sequence. It's not a term because it has to give us whole number. Uh, whole number term. There's no 50.5 times.
That's it. That's it.
So have you marked them?
No, no, yes, sorry.
Okay. So once you meet anyone, you need explanation. So
Okay.
the shapes highlighted on the grid are L8 and L27.
Mm,
Okay. The total of the numbers in L8 is 53. Okay, that means you had all these together to get 53. This is 21, 41, 45 plus 8, that's 53. Okay. Find the total of L27. Okay, we have to add all this together. So that's going to be 33 plus 34, that is 67 plus 30, 97 plus 5, 102 plus 20, 127 plus 7, 134 equal 134. But let me check again. 30, 30, 30, that's 90 plus 20, that's 110. So 334 plus 120, yeah. Then 5 and 7 should be 12. Wait, I think I was checking something else. So let me check it again. 30, 30, 30, that's 90. 90 plus 20 is 110. 7 and 3, that's 10. 120. And 4 and 5, that's 9. It looks like 129. I mean 139 rather. Let me now add them together and see 27, 33, 34, and 35. This is 10, this is 9, that's 19. And this is 9, 10, 11, 12. Okay, it's 129. 129 here. Just for confirmation, again 27, 33, 34, and 35. 10, 9, 19, 1. So this is 9, 10, 12. So 129. That's correct. Final expression for the total in Lx. Okay. Lx will be, let's see. Okay. No, the number we pick is going to be, we must add 10, So that is n plus 10, then plus, I think, because if I say 8 plus 10, no, it's not 10. 1, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 is plus 6. When you go down, it's n plus 6, then plus 7 plus 8. We have n plus 6 first, then n plus 7, and n plus 8. Let's check it. If n is 1, that'll be 1 plus 6 into 1, I mean plus 1 plus 7, then plus 1 plus 8. So 1 plus 6 is 7, this is 8, and this is 9. So this should be 24. 24. Let's check if we get our n here. That'll be 7, that's 8, 8, 9. Almost there. This is 8, this is 7. Okay, yeah. Maybe it's gonna be plus 1. Let me see. Just hold on a bit. I'm gonna continue shortly. So I figured out what's missing here is to add one more n. So if I check and I had, since n is 1, if I add 1, I'm going to get 25 instead of 24. So this is going to be 25. So if I add up 1 plus 7, that's 8 plus 8, that's 16 plus 9 is 25. Okay, let's try another one. Let's say we try from here. What do we have? That is n, which is 38, plus 6, plus 38 itself, plus 38 plus 7, plus 38 plus 8. So let's see what we get here. This is 38 plus, this is 44, plus this should be 45, plus this should be 46. So this would be 12 and 11, that's 23. Then this should be 8, 10, then 17, 173. So, and if we add up all this, it's going to give us 173 if you add up this L stuff. That settles that. So if the grid were continued, which L shape would have 553? So that means n plus n plus 6 plus n plus 7 plus n plus 8 plus 8.
Okay, I've sent that.
Okay. Oh, then I'm going to bring it up now. Just wait. So
Okay.
now I got n plus 8 now equal to 553. So how many n? 1, 2, 3, 4. 4n equal to 553 minus addition of all the numbers 6, 7, 8. 6 plus 7 plus 8. That is 21. So that's minus 21. So 553 minus 21. This would be 2, this would be 3, this would be 5, 3, 2. So let's say 4n equal to 532. Let's find n. Divided by 4, divided by 4. This cancel out. Then we have n equals to, how many 4 in 5? That's 1. Remainder 1. 4 in 13, that's 3. Remainder 1. 4 in this, that's also 3. That's 133. So that means we are saying that it should be L133. L133. Okay, let me get the one he sent so that we can look at the solutions together.
Yeah, okay.
Yeah, what number? Do you get this number one?
Nothing on page one and
Okay,
page two.
okay.
Yeah, yeah. Sorry. So from the one we've done. Uh, so okay. Number number six and number seven.
Number six and seven.
Yes, regarding that page. Yes.
Yeah, is it on the fourth page?
Uh, it's the one before that. Sorry.
Okay, the one before this. That means it's this one. This one.
Yes.
Okay,
Yes.
fine. All right. So the first part of the number six, I think it's only one part or something. It says we should write this equation as equation of a straight line. Okay.
Yes.
So what we need to do is to make y the subject of the formula. To find y. That's what that means. Okay.
Oh.
Find y.
Yeah.
Let's assume that all of the rest are numbers. Okay.
Yes.
X equal to what? 2y minus 1. So how can I possibly find y? I will say I
By
want to,
dividing by two.
yeah, wait. I will say I want to collect like times. Please look up.
Uh, but well, you can't.
I will say I want to collect like times, right?
Yes.
Yeah, because this one I'm not finding it, and this one I'm not finding it. Okay,
Yes.
so I'll take them to one side. Can you see?
Yes.
So y is
So
about to be alone, right?
yes.
So what is disturbing y? That's the two, right?
Yes.
So I'm going to divide all of them by the two. So 2 cancel out here, then I have my y equal to half x, okay,
Yes.
plus half. So if I
Yeah.
equate it, y equals to what? Mx plus what? So what is m?
The gradient, which is two. Yeah, no, the gradient which is x plus. They put x plus 1/2.
Wait, what is M? Look at the board. I'm showing you what M is.
Sorry.
Yeah. What is M?
Half.
Half. And what is C?
Half again.
Half again. Do you understand it?
Yes,
So
I do.
we've successfully represented the equation given as equation of a straight line. Is that clear?
Yep, it is.
Then number seven says the same thing we want to do in number seven, just literally changing subject of the formula, okay?
Yes.
Let's assume this is the formula P equal to square root of something, okay?
Yes.
To remove a square root, you must use square. You must use what?
Yes. Square.
Square.
Okay.
If
Yeah.
it's a cube root, you use cube power 3, right?
Yes.
If it is fourth root, please look at this. Let's assume they give you P equal to fourth root, okay?
Yes.
2h over 5.
But then you times by four, right?
Yeah, we will put power 4.
Yes.
You understand?
Yes.
We put power
I do.
what?
Four.
So that it will remove that root. Then we're going to have 2h over 5 equal to p raised power 4, right?
Yes.
But that's not the question, so let's forget this one. Now let's deal with the question. This cancel the root. Then what do you have left?
P squared equals 2h/5.
Or simply put, 2h over 5 equals to p squared, right?
Yes.
Since you are looking for h. Then multiply both
Yeah.
sides by 5 so that 5 can go
Yes.
away from the bottom. Is that clear?
Yeah. So
Then you have
5p
2h equals to
squared.
what? 5p squared.
5p squared.
Then you divide both sides by what? 2.
Two.
So
Yeah.
h is what?
Uh, 5p over.
5p
Wait.
squared over 2,
Yeah.
right?
Yeah. 5p squared over two.
So is that clear?
Yep, it is.
Okay. So if you follow the one I did in yellow in this part, this is the same thing, up to this place.
I see.
Then which other number?
Okay, so going to the next page,
Excuse me.
please. Number, yeah, number seven, please. For the next one.
Number seven. Okay, yeah. Number seven.
Yes,
Number
but
seven is
part
is
B and C.
is kind of funny. That number seven is kind
Yeah.
of, you don't have to be a good mathematician to know this, but you just have to reason. Okay.
Hmm.
Okay, now let me before I did they by chance get 129?
Yeah, I got one that as well.
Okay.
So I don't need help with that one.
The other side, was it by chance L133?
Um, what for
The
the expression?
for the last part.
For the last part, they just put 128.
One to
Yeah,
eight, right?
yeah. For part C, they put 128.
1 to 8. Maybe there's something wrong with what I did here. But for the second part, what did they put?
Uh, L. No, sorry. 4x plus 21.
4x plus 21. That's correct. Because this is what I brought out. I brought out n plus 6 plus n plus 7 and plus n plus 8. So if you add all the n,
How do you
1, 2,
solve
3,
it?
4, I got 4n. Then 6 plus 7 plus 8 is 21, right?
Yes.
So
Wait, how do you
now,
solve this?
hold on, I'm going to explain. But I want to see why maybe I did something wrong in the subtraction or something. So if I use 4n plus 21 equals to 533, then I have to subtract. Yeah, this is. Can you see what I did here? 533 minus 21.
Yes.
So 3 minus 1, 5 minus this, and this is 532. So if I divide by 4, 4 in 5 is 1, right?
Yes.
4 in 13 is 3, which is 12. And 4 in
Yeah.
12 is 3. So it should be 133, not 128. But let me explain what I did. Okay?
Mm.
What I did
Okay.
was
Yes.
that I tried to study what spaces the something covered. Okay? The L covered.
Yes.
So it covered up to 4 boxes. So one, two, three, 4. Now I now know that, okay, from 27, what do I need to add? One, 2, 3, 4, 5, 6 to get 33, right?
Yes.
So that means whatever n is, whatever the first thing is, I call it n. Then I add to that n, I had 6, okay? If I must add the second one, this is the n, right?
Yes.
Then n plus 6 should give me this, right? That's
Yes.
the second. Then n plus
I would
7,
never.
okay? Then n plus 8 for the final laps, right?
Oh, that is complicated.
Yeah, hold on. What do I mean is that, okay, I would say, let's assume n is 1, right? Can you see me on 1 here?
Yes.
So if n is 1, I put
Yes.
1, then 1 plus 6 will give me 7, right? Can you see
7. Yes.
7? Can you see 7 under it?
No.
No, it's 7. Can you see this is 6, right?
Oh yeah. Yeah.
Because I wrote on over it.
I.
You understand?
I see.
You
Oh,
understand?
I see now.
So
Yeah.
then the next one will be 1 plus 7, which is 8, right?
8.
And the last one will be
Yeah.
what? 1 plus 8, which is what? 9.
9.
So I'm going to add up everything. So 1 plus 7 is what? 8. 8 plus 8,
8.
16. 16 plus 9
16.
is 25. So if I
25.
had this, it's going to give me 25, okay? Because
Yes.
literally what I'm adding is what? 1 plus 7 plus 8 plus 9, which is 1789, right?
Yes.
Good. Now if I go back to anyone, let's say I'm trying this one, okay? N is 50,
That's
then 50 plus 6, right?
56.
Then 50 plus 7, 57,
57.
and 50 plus 8,
58.
58. You understand now?
Yes, sort of.
Wait, let me write it properly. So 50 is the first term. I said you should add 6, you should then add 7, and then add 8, right?
Yes.
So that is plus another 50, plus 6, then plus another 50, plus 7, plus the last 50, plus 8. So this is just 50, then plus 56, plus 57, plus 58. Can you see it under here?
Yes, yes,
You
yes.
understand now?
Not really. I
Wait,
feel like
wait,
first
wait,
explain.
can you see it under this something? Can you see my L?
Yeah, 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 yeah. I can see the blue L. Yes.
On the blue L, that's what I'm saying. So 50, then 56, then 57, then 58, right? And you can see
Yes.
that's what I arrived at. Yes or no?
Yes.
So that means to get the
Oh.
sum without picking them, I could just go back to my formula. Where is my formula?
But
Here.
why do we go from 50 to 56?
Yeah, I follow this formula.
Oh.
I said n must, if you pick a particular n, you must add 6, right?
Yeah, but why do you have to add 6?
Oh, you have to add 6 because I followed this pattern that they showed me here. I discovered that you must add 6
So
from
it's 20.
27 to get this, right?
Yeah, 33, yes.
Then you must
Then
add 7
33.
to get this. You must add 8 to get this, okay?
But 33 plus 1 is 34. And 34 plus 1
No,
is
I'm
30.
not considering this. 27, from 27, I add 6 to get this. 27,
33, yes.
add 8. I mean, add 7 to get this. The same
Ah, I
27,
see.
add 9 to get, I mean, is it 9 now?
Okay, yeah, that makes
Add 8 to
sense.
get this, okay? You understand?
Yeah, I
So
get it
if
now.
you're picking another one now, if you pick this one, that means from 62 you add 6 to get 68, right? 62
Yes.
add 7 to get what? 69. 62
Yeah.
add 8 to get what? 70.
70.
But instead of having to be adding and adding and adding, we could contrast this formula, okay? By
Yes.
adding all the n's together. N plus n plus n plus n. How many n?
N plus N plus N plus, that's 5N.
4n rather.
Yeah,
One,
4N,
two,
sorry.
three, four. 4n. Then what's the addition of the numbers? 6, 7, 8. That's 21. So that means for
I see.
anyone you're looking for this sum, you must get 4n plus 21 to get it.
Plus 15.
Now for the other one that they told us, okay, the L27, if we want to get L27 now, all we just need to put is to put 27 here, okay?
Yes.
4 times 27, then plus 21. So 27 times 4 is what? What is 20 times 4? 80.
80.
7 times 4, 28.
Twenty-eight.
That'll be 108, right?
Yes.
108 plus 21 is what? 129. So it works for this, right?
Yep.
Okay, fine, because they said L27. They now ask us the next one. Now said for 533, what L will it be? Okay,
Yes.
we say if the grid were continued, which L shape would have a total of 533? That means we should say 4n plus 21 equals to what? 533, right?
Yes. Yep.
Then we should say 4n equals to 533 minus 21. Is that correct?
Yes.
Okay, I think I made a mistake in my subtraction here.
Uh,
So let me see. 4n equal to 5 instead of 3 minus 2 to give me 1. So that means their answer is correct, okay?
yes.
So I say 4n equals to what? 512, not
5.
532.
12.
So you divide both sides by what? 4.
Yeah.
So n equal to, how many 4 goes in 5? 1. Remainder 1.
God.
4 goes in 11. 2. Remainder
2
3.
times minus
4
3.
goes in 32.
8
8.
times.
That's 128. That's L 128, okay?
I
Instead
see.
of 133 that I put there, bill 2.
That's quite technical.
Yeah, that's quite a. But it's still kind of straightforward if you can really
Yeah, I can
study.
understand it.
They could give you another one that will go down not by 6, go down by 10. Imagine they continued A and they said 6, 7, 8, 9, 10. They now continue 11 from A.
Mm.
So that means if you are jumping down from 1, you're jumping to 11.
Yeah.
It won't be n plus 6, it will be n plus 10, okay?
Yes.
Then to get the subsequent ones, you have the n plus 11 and n plus 12, okay?
Oh, yeah. Okay.
So they could vary anything. You understand?
Yeah, I do.
Okay.
Can I just get some notes down with that, please, sir?
Yes, you can get it down, please. All right, viewers. Thanks so much for watching. We'll continue shortly.
Okay, scroll down a bit, sorry, please.
Okay. Yeah, is it okay now? Or this one?
Yes, it is. Yeah, yes, it is.
Okay, okay. All
Mm.
right, we're going to continue shortly.